All right, let's go ahead and get started. We got a lot to cover. Today is going to be kind of a partly an informational session, and then we're going to go ahead and go have some fun and write some code. But these four topics are what's going to be discussed throughout the course of this video: interfaces, dynamic binding, abstract classes, and secure programming. So let's start with the one that I forgot that belongs on this list that starts the whole thing out is polymorphism, and kind of what does that mean? And what polymorphism means is two like items, two objects that are the same. However, they behave differently. And when I say behave differently, what I'm talking about is runtime code. So a function. So that definition, we're going to expand on that and write some code so that you guys can kind of visualize that. And then what we'll do is we'll continue on. I may have to break the video up in parts, but we'll continue on with implementing it. Now, polymorphism is really a good way of having code that you don't have to reproduce, and that's kind of the idea. But also, it allows you to do things like dynamic binding and secure programming. It's part of that whole thing. It doesn't allow you to do it, but it's part of the whole grab bag of capabilities of why inheritance, composition, and object-oriented programming is kind of the way to go. So two objects that are the same, however, they behave differently. And what are we exactly trying to gain from this? And here's kind of like, let's begin with the end in mind. Here, what I want to be able to do is I want to be able to create some animals, but I want those animals to be a tiger or a cow, but I want to be able to treat them all like animals at some level. So I don't have to write extra code at the animal level for a tiger or a cow. And that begins with our animal object. And what we're going to do is we're going to have two like items, and I'm going to demonstrate how those two like items, how you implement polymorphism. Because here's one of the main things that people have an issue, or I have an issue with, is a lot of books will confuse polymorphism and dynamic binding, all that stuff gets kind of confusing. Polymorphism is something you make happen. We don't have to have any tricky abstract classes for polymorphism. But it is a way we can implement polymorphism with abstract classes and dynamic binding in a much better way for the begin and end in mind that I'm talking about. And I'll kind of give you an example of where we're headed. And what we want to do is, this is kind of the main class of the project that I'm going to be working with. And in this main class, I'm going to want to be able to do something like this. I want to say, hey, I want to create an animal array. And that animal array will be an array of animals. Then it'll be 4. Now I'm writing just whatever code here. This is just pseudocode. It's probably not going to compile at all. But I want to create an array of 4 animals. And basically I'm just setting up an array of pointers to animals. And then I want to go to each of those animals. And I want to create not a new animal here. I don't want a new animal. Remember, this just sets up the array. That's all that's doing. It's actually not creating animals. It's just setting up an array of 4 pointers to each animal. And what I want to do is I want to be able to do this. I want that animal to be a tiger. And then I want this animal to be a cow. And now I have an array of animals that I can draw and render onto the screen. And I can call the render function at the animal level, and it'll propagate out to render the tiger differently than the cow. And that's kind of like, that's one of the big ideas here is we can easily treat them as all animals with code at a higher level, but have them enact their own specific behaviors on their own. It's an automation, and it's beautiful and wonderful. And that's the way you want it to do things. This is also secure programming and with dynamic binding. And I'll kind of add more to that as we continue. But this is kind of the reason for object-oriented programming, because of that capability of dynamic binding and secure programming. So that's the end that we're heading towards. So how do we get there? And what we're going to do is we're going to start with the animal class. And I want to kind of go a little quick here. So we're not going to create a new package for every class that we do. So what I'm going to do is instead of creating a new package, what we're going to do is we're going to, instead of going to source packages and saying new class, I want to go to the chapter 9 polymorphism and click on that and say new class. Or add, or yeah, I think it should add it to this package. So let's go ahead and do new Java class and project source packages. That's the one we want to make it into that one. So we're going to do this one. Oh, animal. This is going to be the animal class. And let's go ahead and flesh the animal class out. It's going to be a real simple class. It's not going to do a lot. It's only going to have a variable that describes the animal. It can be a string, and then what it will have is just a simple constructor, default constructor, nothing crazy. But what it's going to have that we're going to actually work with is what I call the eat function. So this is going to be a function that is going to implement how an animal eats. Now, here's the thing is because we go back to the definition of polymorphism was when two like items behave the same but also differently. And let's go back to that definition. So, two objects that are the same, however they behave differently. Here's also a little bit more to that definition, because not only do they behave differently, but they can also behave the same and differently. So two objects that are the same, however they behave the same and differently. Okay, so now we got that one going. Let's head into this guy, and let's just make it happen so you guys can visualize it and see it actually, in the flesh. So we got this function eat, and when I say behaves the same, and differently, what I'm saying here is that this animal is all animals are going to behave the same when they eat. So what I want here is I want just something that will identify that I'm eating like an animal. And when you have a behavior or a function that's going to work upon an object, you want that function to be in line with the purpose of the object. So this could be a draw function for the part of the drawing that needs to be done for an animal. When you render it to the screen, and then you would override it with a draw function to draw the tiger versus the cow. This is a very simple example. So what we're going to do is we're going to go ahead and print well, how do animals eat? How do all animals eat? And so what we'll do is we'll say, well, all animals have to open their mouth to eat. So let's just say the animal opens its mouth. And just imagine that we added maybe whatever. It's just, that's kind of the behavior. So opens its mouth, but the animal's not done eating, is it? If all animals need to open their mouth to eat, is there a way that animals behave differently also when they eat? Because not all animals eat the same. And that's where the polymorphism is. So opens its mouth, and so behaving the same. But here it's going to open its mouth, and then also we're going to have it behave differently. So again, as I'm saying, polymorphism is not tricky. You make it happen. You don't have to have all these tricky abstract class stuff. Okay, now let's go into our next class that we're going to build. And that is going to be our mammal class. And our mammal class is, well, let's see. How do mammals eat? Well, mammals eat... Well, let's just get into class and figure it out. Okay, so I'm going to go back up here, add the package. Or not the package, but the class. What we're going to do is mammal. And let's just go in and copy an animal and bring it in. And I'm just kind of okay, there's our mammal. So a mammal, how does a mammal eat? Opens its mouth and well, I'm gonna get stuck on how a mammal eats here. Well, let's say here, a mammal eats because an animal eats by opening its mouth, and a mammal can eat by opening its mouth and you know what? Let's just say here, a mammal opens its mouth, looks around for danger. Yeah, that actually makes sense, because if you're out in the wild and you're getting ready to eat, you're looking around for somebody that may take your food from you. Hey, done. Okay, that's how a mammal eats. Looks around for danger. And an animal eats by opening its mouth. Okay, so now what we're going to do is we're going to add a tiger and a cow. So here we go. We got two mammals that are also animals. And we're going to have a tiger and a cow. So let's go up over here and let's just keep our thing that we had in our copy paste. So I'm going to go tiger here. Okay, and I'm going to go ahead and rename this to tiger. We got to implement the inheritance scheme though. That's coming up. Okay, but how does a tiger eat? Well, a tiger is an animal, so it opens its mouth. Tiger also is going to look around, and then it's going to eat meat because it's a tiger. So that is for how a tiger eats. Now what we're going to do is we're going to create the cow. Let's go here to packages, new Java class. Let's go cow, finish, and we're going to do the same thing. Paste it in. And now this is going to be the cow. And the cow is going to open its mouth, look around, and eat grass because it's a cow. All right. So now we have all these values. You know, what's our inheritance scheme going to be? Well, that gets us back here. What we're going to do is we're going to have an animal as our base class, and the mammal inherits from animal here. And then the tiger inherits from mammal, and the cow. The cow inherits from mammal. Now, if you look at it from, bottom up or top down, it doesn't matter, but we're going to be discussing the differences between these two diagrams when we get to dynamic binding, which this example will be used for. So we need to make the mammal inherit from animal, and the tiger and the cow inherit from mammal. So let's go ahead and go back to our code, and we are going to say extends mammal here, and that's for the cow. For the tiger, extends mammal. And then, we got to do our imports too. I'm going to get to that. Then we got to get to the mammal. That one extends animal. Okay, this one, let's do our imports now. Import, I think we should just do that. No. Really? No, I think, I might have to, I think so. Oh, right. Okay. Okay. Yeah, I got to do that. Animal. Okay. And then we're going to go to tiger and import mammal. And then we're going to go to cow and import mammal. Okay. Oh, semicolon. Don't forget the semicolons. Better go check them all. Save all. Lay on that save all function. All right, save all. Okay, there we go. Good. There we go. Okay. I don't think we got any errors. Let's go ahead and build and clean. Okay, build successful, so we're good. Let's see. Now let's go ahead and look at what we've got. We have an animal class, but what we want is we want to create a tiger and a cow, and we want to have them eat. That's how we're going to demonstrate this. So I'm going to say tiger, Simba equals new tiger. Okay. Then I'm going to say cow Betsy equals new cow. Now I'm going to have them eat. But here's the thing, is they're going to eat the same, but also differently. That's polymorphism. So let's look at them. And I did forget something because we actually haven't got polymorphism yet. And I'll talk to you about that. Let's use Simba as an example. Let's set our breakpoint here and go ahead and examine when Simba gets called. I'm going to do a step into here. And you see that the eat function for the tiger is called appropriately, but that's it. It just says eats meat. What happened to the tiger opening its mouth, looking around, and then eating meat? And that's why in the previous some of the previous videos I kind of tell you that your job as when you inherit from a class is to understand those functions that you've got to override and implement, like the toString and stuff like that. But also, not only that, but you've got to call the base class constructor. It's very important. So do your best on that. But here is what we have to do is, well, the tiger has to eat like a mammal, and the mammal has to eat like an animal before the tiger can eat its meat. So here's what we're going to change to make polymorphism happen. Remember, there's no magic to polymorphism. We're going to get into the magic part and the things that probably make you a little blurry-eyed, abstract classes, dynamic binding, that stuff. But that will be really simply explained too as well. But here we go. Let's implement the eat function polymorphically so that they eat the same but differently. And what I'm going to do is I'm going to go ahead and stop this. And I'm going to go to my mammal class. And I'm going to say, okay, Mr. Mammal, I want you to go to your superclass and eat first, like a mammal, before you eat I want you to go to your base class, your superclass, and eat like an animal before you eat like a mammal. And then we go to the mammal class, or the cow class, and we say, okay, cow, I want you to eat like a mammal before you eat like a cow. And then you go to the tiger and you do the same thing. Oh, backwards. I just made a big boo-boo. Okay, let's do that. Wrong. Okay. Always do the base class first. All right. Now let's look at how the cow eats. And what we're going to do is we're going to add the tiger and how the tiger eats. And we're going to walk through it. And that's going to be the polymorphism part of this series. So let's go ahead and get into the main portion of our program, and let's add the tiger, Simba. Let's have Simba eat. And then what we're going to do is we're going to examine both. So I'm going to set my breakpoint here, and we're just going to see what happens. Okay, so I'm going to go ahead and run it. Oh, duh. I was talking about cows and tigers, and I'm mixing up my cows and tigers. Okay, let's do Betsy here. All right, now we go. All right. Okay, now we're going to do step into, and Betsy's going to eat. Oh, that was step over. Whatever. All right, run it again. Step into, Betsy's going to eat. The cow is eating. Okay, so then the cow portion, the eat portion of the cow calls its, base class. And we go to the mammal. And now the mammal says, hey, I need to eat like an animal first. It calls its base class. We go to the base class. And that is then where we can start eating. So the animal opens its mouth, or opens its mouth. This animal happens to be a cow. Then we come back and the animal looks around for danger. Betsy then likes to eat some grass after she says, oh, it's safe, I ain't got any tigers around. Now Simba's ready to eat. And Simba is a tiger, and Simba's still got to eat like a mammal, just like just like the our our cow. I got to restart this so that we can go through. I'm going to do a step over here. Step into. Okay, Simba eats. Step into. Simba wants to eat like a mammal first. Step into the mammal. We're eating like a mammal, but oh no, we got to eat like an animal first. We go in and we eat like an animal by opening our mouth. We look around. Is there any other tigers nearby? No. And, oh, I'm Simba. I like to eat meat. And that's polymorphism. And that's also what I call top-down binding. Top-down binding is when you come in through the tiger down to the mammal, then down to the animal. That is normal binding, and you can, to have dynamic binding, you must have the animal as an abstract class. That we're not there yet. We're going to get there where we talk about it. But this is the example of top-down binding. So top-down binding is when when you step through your code and you look at the runtime. That's what I'm talking about when I say binding, is the runtime. What is it doing? And it goes from the tiger's eat function, then to the mammal's eat function, then to the animal's eat function. That's the top down. That's that's binding. It's how they're bound, is with the inheritance hierarchy. So when we get to dynamic binding is the opposite. Dynamic binding is tiger. You start with the tiger, or you start with the animal, go out to the mammal, then go out to the tiger. Dynamic binding is secure programming, and we'll get to talking about that shortly when we in the next video for abstract classes. So, polymorphism, top-down binding. This will be continued. Thank you.